Hi guys, my name is Yipeng. I'm in Singapore. I'm pretty passionate about machine learning and specifically applying it to finance and mostly to the markets. So I'm doing this video to basically apply NLP, natural language processing, to reading corporate filings and getting some sentiment, and then doing a simple backtest based on that. I think the past 1-2 years there's been a lot of advancements in NLP, particularly around like Transformers, things like that. I've written a few articles on NLP as well on Medium. If you're interested, you can check that out. Basically today I'll run through like kind of like the first iteration of what I've done, which is basically taking the data, the corporate filings, running them through a BERT model, and then trading them based on the sentiment score. So yeah, hope you enjoy it. Okay, let's start basically. So I think there are so I'm going to use the Google Colab. If you haven't used it before, just go check it out. The URL is here, colab.research.google.com. It's very useful for running like GPU stuff because there's like a free GPU. It's not very strong and you can't use it for very long. But for like for our use cases, I think it's pretty decent. So what we're trying to do is trying to beat. Yeah, so it basically is like a Jupyter notebook, but it's like online, hosted with Google, and you have NLP, and you have a GPU. So click here, you can see there's a GPU accelerator. If you don't have it, just click on it. See? Now it's going to allocate it. Then once it's connected, you can basically use it. So it's pretty cool. It's going to do a quick authentication. Yep. Okay. So in terms of getting the filings, I'm doing this specifically for Singapore, so I won't really go through exactly how you do it for Singapore, because I mean like you may have your own use case, and basically it's really just like using Selenium to just script the data, and then you finding the XPath to download the specific data, get the links, things like that. So you can use that. You can use my link as a starter, or you can just adapt that to your use case. So the first part is basically done. After you download the data, you basically have this. So I saved it here, where I have this just whole bunch of like data of different companies in trader in Singapore. The one that we're going to look at today is this company called AEM. AEM, Yahoo Finance. Let's take a look at their price chart. They've been doing pretty well, I think. So if you look at the past 1 year, it's been pretty nice, I think. Yeah, it's been kind of going up. So we work with that. So the first thing we want to do is kind of after we get the filings downloaded into like PDFs. Like if you open one of them, it looks like a PDF. What you really want to do is be able to scrape them. So in order to scrape them, I guess we want to basically I guess how we call it is like pass the PDF. So we're going to pass the PDF, and how you do that is actually, let's close this, is to use like a PDF scraper. So I found like a pretty nice kind of like a little list of useful libraries for reading PDF. So I think I tried almost all of them. The one that I really liked was this one called PDF Lite. So I'm going to just install it right now because it's super fast. So you can install Lite. It just looks at it basically just takes your PDF and then like extracts out the text, or if you actually want the images, you can do that as well. So I think it's pretty useful. I'm just gonna copy this out. Well, of course, before that I gotta get a list of all the documents, right? So this PDFs equals to globe. So I've already got globe. My data sources are all in this subfolder. So I'm going to do this AEM.pdfs. So it should give me like a list of 150. While we're waiting, let's do this. NLP PDFs. So let's just run one of the documents. So you can see it's nicely parsed out the text. So this is important because we need to feed the text into our NLP model. So we need it to be nicely kind of parsed out. So we got this. That's pretty good. Then we basically have like a tool to kind of pull out the text. So now we want to pass the text into a model. So how we do that is we use basically use a transformer model. So the one that I'm going to use today is pretty convenient. If you Google like FinBERT, there are like two versions. This one is more straightforward to use because it already has classified on a financial document for sentiment classification. So I've written an article about like transformers and how to use them for NLP, especially for financial sentiment. So you can check that out. Or you can check the paper, which is quite nice to read as well. But essentially, what we're trying to do here is we are taking a model that has already learned English and also learned how to classify financial documents in terms of sentiment. So this is very useful for us to be able to read news or read corporate filings, any text, any financial text, and be able to extract out the proper financial sentiment. This is quite important because every industry, every domain has its own jargon, has its own language, so to speak. So you really want a model that has been configured, fine-tuned on your target corpus, as close to your target corpus as possible. In our case, it's the corporate filings, but for this model, it was trained on this financial phrase bank. So it's not exactly the filings, but I think they're close enough. So we use that for now and see how far we can go. So to actually use the model, we first need to install like this I think Transformers, yeah. This library called Transformers. Essentially, it's basically the architecture that really changed the way computers have actually read English for it, basically. So if we go into here, it's called FinBERT. So it's basically using a version of BERT, and you need to download two things. First thing is the config file here, and you need to download their model, which is here, sentiment model. So if you download it, it will show up as like PyTorch underscore model.bin here. So you can see, yeah. So I've already downloaded it here. So I will, yeah, direct our model here. So if you come here, you can see what we want to do is there are a few ways to use BERT. You can use it for doing mask language modeling. You can do it for sequence classification, which is basically what we want to do, classify a sequence of text. So it's actually really straightforward these days to actually run any model. You just do this, and remove the silly. Let's run that first. So in terms of tokenizers, we can actually use the BERT tokenizer because they actually use the same tokenizer, so they didn't reinvent anything. So model-wise, let's use this. So I just have to point it to my file, which is here. Going to, let's see. This doesn't work, never mind. Slash, let's see. PyTorch, let's go model.bin. Config equals to config. Just see if that works. You can skip that. Errors. Okay, so you can see this error in saying that there is it's trying to copy a parameter that is 3.768, but the model itself is 2. So the default BERT for sequence classifications is actually has only 2 labels, positive, negative. That's a typical kind of like sentiment classification in the general academic NLP task. So, but for FinBERT, they actually train it on like three labels. So it's positive, neutral, and negative. So what you need to do is kind of tell BERT that, like, tell Transformers that actually we have 3 labels. So I think if you do this, then it will be okay. There you go. So now let's kind of test out what is the results of the model. So we had a great year. For example. So outputs are, let's see the outputs. So typically the output gives you like 3 numbers, and what you do is find the index of the biggest number. So this tells you that it's actually the first index that's or I guess index 0 that is the label that the model predicted. So how would you actually know what is a label, right? So what you do is you can look at some examples. So what I did here is you try this, and then just search for like labels. Yeah, so you can see just now you do see that, yeah, it gives you the same thing. Then what you do is label and label just to get a sense. Yeah, so there you go. See label list. Just grab this and use that. So this is probably in the order of the output sentiment. So if you just do an argmax of outputs, and that should give us 0. Okay, touch dot argmax. Give us must be a tuple. Oh, okay. So I think the output is actually a tuple of tensor and blank. So we just put 0 and then like that. So that tells you 0. So if you do this and you just do a label. That. There you go. Yeah, so you positive. So you can repeat the same thing and do it for, let's clean this up so that we run an error. We had a bad year, so it should be negative, right? Yeah, so it seems to be we had a neutral year. It should be neutral. Yeah. Okay, that's pretty cool. So we have a model that can read a bunch of text and then tell you like, hey, this is not correct. So what we do here is we can actually start classifying the model, classifying our text. So earlier on we had this like we were able to print out each page of the document. So instead of printing it out, what we do is let's just create like a sent list, okay? So just for PDF in PDFs. So if you don't call PDFs, it looks a bit like this. It's just a list of files. So what we do is we just do this. Cool. So yeah, I love this one. Just this, and then what you do then is so is this. We just paste this into the. So we don't really need the outputs per se. This was just for us to read it. So we can just go with this, and here's the page. Right? Yeah, that's it. And if you want to simplify one line, let's do this. Yeah, I don't really like too many lines in my code. Makes it easier, harder to read sometimes. But in this case, yeah. So we just do that, and then so for each PDF, my idea is like let's kind of accumulate the score. So let's say we have a sentiment sum is 0. So okay, now we have this, then equals this is this. So we still need the argmax of this. Sent equals the argmax, right? So this gives us 0, 1, 2. 0 is positive, 1 is negative, right? 1 is negative and 2 is neutral. So if sent is equals to 0, then send some send equals 0, send some plus 1, plus equals 1, else if send equals to 1, then send some minus equals 1. So what this says is we start with a neutral sentiment, and then if it's positive we add 1, if it's negative we minus 1, then we have overall sentiment of the entire document. And then we just send this dot pen, send some. Oh. So I'm gonna run this. Ooh. Okay. Yeah. Must be your type string. Okay. So okay. So you actually should do this instead of So it's going to start running. It's going to run for quite some time because what we're doing is we're trying to pass the data into the document, and it's going to take quite a bit of time. But before that, we have another error, which is size does not match the tensor. So if you see file 2, that should give you a hint because typically transform models have like a range of like sequence length. It goes from 128 to 512. 512 is the maximum. So what this is really saying is that like the input text you're giving it is actually more than 512. So you can take a quick look. I think you can just run this. You can just run this and see. Probably a pretty long bunch of text. Yeah. So it's probably more than 512. Of course, this is 512 tokens, so you can't just count the words. Sometimes a word can be multiple tokens, sub tokens. But yeah. So basically, this is saying that there's too many words. So what you're gonna do? What you do is you actually you can do a couple of things. One is really cut up the text into 512 like portions. But I think in this case, I think each page like usually doesn't exceed 512 by much. So I think we can actually just cut out the last few words. We can do this thing called truncation. And I think you just set truncation equals to true. So it's in the tokenizer itself. So let's do this. Truncation equals to true. And we will want we need to give it a max length. So max length equals to 512. So what it's going to do is it's going to just, if it sees this text again, 564, it's going to cut it to 512, then just take the sentiment of that range. And typically that should be okay. Yeah, there are other ways to do it where you can do like a sliding window, kind of like convolutions where you slide a window across the image, you slide a window across the text, and then get the sentiment across. So this allows you to retain more information because sometimes if you just cut into 512, the second portion may not make much sense without understanding the first portion. So the striding part allows you to do that. But for this iteration, let's do a very, very simple one and just do this, and we should stop having that error. So the thing about this is it takes pretty long because we are essentially taking the text, passing it through the model, and then running individually. So a few ways to speed it up is you can actually batch up the data. So right now I'm feeding one data at a time, so that's very, very slow. So that's one way to speed it up. But like to be frank, 150 PDF is not that much, so I think it doesn't take really that long. So I'll just leave it running for now. But like assuming I sped it up, you'll be able to see the list soon. So let me just pause this. Okay, great. Yes, it's done. So what we have here is the sentiment score. So if you look at it, it's under oh, it's only 15. Oh, okay. Yeah. Okay, let's see if I got this right. Again, there was a bug. Yeah. Glitch. Okay, cool. So we got the sentiment score, and what we really want is to really just put it all together nicely. So if we have just make a simple PDF, DF data frame, then send equals to send this, and DF files equals to PDF. So what we have here is then this nice data frame with all the sentiment and all my files here. So we're almost done. Because we have the sentiment here, but typically we want it. You want to kind of like feed it in together with your data, with your price data, which is a daily data. So you probably want to sum up your sentiment if there are multiple files per day. So to do that, we first need to extract out the date. So when I was parsing the data, I actually extracted out the date here. So you can see it's there. So one simple way is just to use regex to really pull out the dates. So so how we do that is let's just do testing my regex skill. So I think let's try this. Date equals to v.match final. Final. So what we want is it's not that hard, but basically regex is just a very nice way to kind of like extract out a specific sequence of words. So D stands for digits, and then W stands for like I think words or characters. Then this bracket says like how many of this like digits, 2 digits, 3 words, and then 4 digits again. I think this should work. Return the date. Yeah. Let's run this. Yeah. Not sure how this will go. Okay. X, yeah. Yeah, fantastic. Looks correct. So date equals to awesome. So now it looks like that. Now we have the date nicely here. So I'm gonna just set it as df.date equals to pd.toDate time df.date. Let's just do this. Usually this is more correct. So just run df and see if it makes sense. Eyeball glance looks good. Fantastic. Then lastly, I want to just set the df.set_index. So put it as an index, it's much easier to do any joins data if we want to, which we will want. Then now we can group by sentiment, right? So we can do a sent equals to df.group by df.index. Sent. Because actually at this point we don't really care about the file name anymore. So if you look at send, you can see it's very nice. There's basically for each day there's sentiment. So of course you see that it's actually a bit disjointed, so that could be a problem, but we'll worry about that later. So in terms of backtesting, now with sentiment, right, we can use it to backtest against the actual stock price and see if let's do a simple strategy. If it's positive, let's buy it and sell it the next day. If it's negative, don't do anything, because in Singapore it's very hard to short stocks. So let's make it more practical. So there are really like 2 ways to kind of do backtesting. Two common libraries. One is like Zipline, which is the backbone of Quantopian, or BackTrader. So I kind of like BackTrader because the kind of like the ethos of it, or the principles of it, is pretty nice. Like they just want to make it easy to use, and that's really the objective. Like it's simple. So to show how simple it is, let's kind of look at like the quick start example, and we can actually use that to really just run our very basic strategy, because it's basic, right? So yeah, I think this. So of course you got to pick the stock first. But yeah, let me put the link here so you guys can take a look. While we're waiting, I think shameless plug, if you guys want to read about NLP sentiment, I wrote a little article on that. You can take a look. And if you're interested to know what exactly does tokenizing mean, I've also written an article on that, just to kind of illustrate like what you can do with like how different tokenizers are different. I think it can be quite important if you want to like really go deep into this. So yeah, feel free to check it out. So yeah, so we've installed BackTrader. So if I split this up into two parts, which is one part is the actual strategy, the other part is the running itself. So this part runs. So this part fails because no such directory. So this thing is actually not, this file is not there, so it can't run. So what you want to do is what you need to do is do two things. Basically get like the historical data. Second thing is to get feed our sentiment together, combine our sentiment together. And the easiest way I found was really to Yahoo Finance, AEM. So the most straightforward, for this example, let's just do this, where we just go and download the data here. Very, very simple. Let's download it. I've already downloaded it beforehand. So let's just call it AEM equals to pd.csv. Oh, no such file. Unfortunate. Double check. Still like underscore. Yeah. Okay. So you can see I have this. So this is like a good format, OHLC with like the close, adjust the close and volume. So this is what like a typical kind of price feed that BackTrader expects. So we can just use this. Yeah, I think ultimately if you wanna productionize this, you need to kind of do the API directly instead of downloading it. But I don't think it's too hard. But I was kind of like just want to get this running quickly instead of figuring that part out. But basically, so we have our AEM here and we have our send, right? So first thing I'm going to do is to make it the same in the sense like the index is the date. So let's just do this. Date. Let me just do that. Let's see if it's correct first. That's good. Cool. Yeah. And now let's just do a combination. So usually I just do a merge first, just in case. Left index equals to true, right index equals to true. So if you do that, you see, oh, okay, it's nicely merged. But the big problem here is that you're jumping the dates. Initially, you had the dates in sequence, but now it's all kind of inner joined. So you're missing out all the intermediate dates, which is a little weird because if I buy on, let's say sentiment is positive here and I want to sell the next day, I can't really see the price. So what we want to do is just change the how equals to like left. So what this means is it's gonna take the left data frame, which is the AEM, and then gives you all the prices. And if there's no sentiment, it's just gonna give you NAN. So let's do that. It's probably better than .fill NA0. So do this. Good. It's gonna give you the sentiment 0 for those days where there is no sentiment. I mean, of course, you can fill things like that. But yeah, for simplicity, let's just go with that. So I call it AEM, right? Okay. Oh. Okay. So for BackTrader, if you want to put in another data set, what you do is it's a little tricky, to be frank. Like it's my first time using it, so I find it a little unintuitive, I would say. But yeah, let's just copy this file. So the thing is, because if you just look at if you just look at the pandas data class, it really only expects this few parameters. So it doesn't expect the actual one. So what we do is we need to create like a kind of like a new class to kind of just subclass that pandas data. So what we're going to do is let's just call it like uncreatively, let's just call it $10. Okay, so there are kind of like two parameters inside this, kind of like two things you need to kind of initialize. So I think one of it is called lines. Just do some referencing. Yeah, so it's just lines, and in our case we have this sentiment line here. So lines are basically what you feed into the BackTrader, and then you have the params. Yeah, and actually that's about it. It's Penny's data. Okay. So just feed in like that. Okay. So then now instead of this, we just put this in and put our AEM. Cool. Just initial. Okay. So this is a bit strange. Yeah, so yeah, it's a bit funny, but basically what you see is it's actually running it's actually running the script. So whenever there's a positive sentiment, it buys and then sells it. Oh, but this is not based on the sentiment yet, because if you look at the actual strategy, which is what I haven't talked about here, is what it buys is when the current price is lower than the yesterday's price, and if yesterday's price is lower than the day before's price, then you do it. So what we want to do is actually want to trade on the sentiment, right? So how you do that is let's close some stuff that's not so important. So because you've already fed in the data, sentiment data, what you can do is just change this to send close. Send. So now you actually have the sentiment score. So if we do a very simple one, if more than 0, then you buy, right? Which is basically what we're trying to do here. Yeah. Now if we run this, it will only buy when there is data sent. It's not picking it up. Data sent, self.data sent. So it doesn't seem to be, yeah, I think it's just self, right? Yeah. Okay, so now it only buys when there is a positive sentiment. And oh, you see, not bad, we made some money. So I think it's Cerebro.plot. I thought it was false. So you can see a nice kind of like a nice plot of like when they bought and when it's positive. This 3 positive, this 4 were negative. Overall, still made some money. So that's pretty not too bad, I guess. Yeah. So you can tweak a couple of stuff, like you can tweak like, oh, when do you exit? So let's say we want to exit immediately as soon as possible. Let's see if that improves things. Quite a lot of things you can tweak here. It kind of makes things worse, so maybe let's keep that 5-day. Let's keep the 5-day. Let's just keep it at 5 days, shall we? Let's keep it at 5 days, or like 5 time bars, in this case it's 5 days. Then what else we can do is like, maybe like sometimes for some, if you look at the sentiment, right? Send dot sort score values. Do that. Yeah. Sending equals to false. Let's see the first tag, for example. So you can see like actually there are a lot of these where it's just 2, and sentiment may not be very strong. So it could be possible that if we only buy when there's very strong sentiment, then there could be more stronger like gains. So let's try doing that. yeah, and you can see like went up by a bit, like you pay like $3 more or something. So yeah, we can play around with that, and yeah, actually most of the trades are positive. The sentiment is very, very positive. So I think this is something you can play around with. I think it's pretty cool. So we have gone through like an end-to-end where we imported the stuff, got the filings, passed the data, run a state-of-the-art, more or less, NLP sentiment classification, and got the backtest. And yeah, I think this is a good place to start. And yeah, who knows what we can do with this, right?